Okay, let's take a look at using factoring to solve equations. So in our first example here, we have x squared minus 64 is equal to 0. This guy actually looks like an expression that is the difference of squares. So in the form of a squared minus b squared, and we took a look at how to factor expressions in the form of a squared minus b squared, and we can use this template, square root of a squared plus minus square root of b squared, and this method would give us the two conjugate factors that could be expanded into this expression. So I'm going to kind of factor this guy out. So we're doing, in this case, a can be, well, a squared here can be x squared, and b squared can be 64. And what I want to do here is I'm doing the square root of x squared plus minus the square root of 64, right, is equal to 0. And the square root of x squared here is x, plus minus square root of 64 here is 8, is equal to 0. My two factors are x plus 8 times x minus 8, right? Now that I have this point, I want to solve for my values of x, right? So if I want to solve for my values of x, you notice here that these two factors are multiplying each other, and the whole point of an equation is that the left side, which is this side, has to equal the right side, which is this side. So what we want to do here is, we know that anything times 0 will give us 0, so we just have to let each of these factors equal 0. We just have to find a value of x that makes each factor equal 0, right? So I'm going to start with the factor on my left. I'm going to let x plus 8 equal 0, so we can just do a little bit of algebra here, and we get x is equal to negative 8. You can also let x minus 8 equals 0. I'm going to move the 8 here, and then x can be equal to positive 8. So therefore, x can be equal to plus minus 8. If you wanted to check to see if your answer works, right, you can substitute x is equal to positive 8 or negative 8. I'll just use negative 8. Into the equations, you get negative 8 squared minus 64 is equal to 0. Negative 8 squared is 64, minus 64 is equal to 0, and you can see that left side is equal to right side, so it does in fact work. Okay, let's take a look at the question on the right. So here is another example, right, and once again this kind of looks like the a squared minus b squared technique, right? So it's a difference of squares, so let's factor out this expression. So let's call this guy a squared, let's call this guy b squared. And what we want to do here is we're using a template, square root of x squared or square root of a squared, right? So square root of a squared here is square root of 100 plus minus the square root of b squared, which is 16x squared, is equal to 0. So the square root of 100 is 10 plus minus the square root of 16x squared is 4x, is equal to 0. Now our two factors are 10 plus 4x times 10 minus 4x is equal to 0, and then you can just let each factor equal 0 to solve for x. So we have, I'm going to let 10 plus 4x equals 0. If I move the 10 here, I get 4x is equal to negative 10. I'm going to divide by 4 to both sides, right? X is equal to negative 5 over 2. Okay, so that's one of our solutions, right? We can also let 10 minus 4x equals 0. I'm going to move the 10 to the other side. Negative 4x is equal to negative 10. I'm going to divide by negative 4. And in this case, x is equal to positive 5 over 2. So therefore, x can be equal to plus minus 5 over 2. Okay, and that's how you can solve these expressions, well, in this case, equations.